I think there's almost no one because there's like a winter storm going on, and
I,
it has been awful outside.
yeah, where are you at?
I'm all the way in Lehigh, so I go to school in the campus, in the Taylorsville campus, so it was a nightmare coming back home.
Oh my gosh, I know. I heard there was some instructors that were like, I don't know if I can get up there or get to, campus today. But where I'm at, it's not very bad. So it's just so interesting. So that's okay.
Yeah.
All right, well, let's get started talking about 3.7, which is the sum and differences of cubes. And then we'll also talk just a little bit about just a general approach to how to do factoring, just to give you some tips and tricks on the type of factoring you should do for the type of polynomial you have. Okay, so these two things here at the top are kind of little formulas that you need to follow when we are trying to do these sum and difference of cubes. So, and we can tell that we're going to use this because we have something cubed minus something cubed, or something cubed plus something cubed. And so we can see that these formulas are pretty similar to each other. Like we've got an A and a B in that first parenthesis. It's connected by a subtract sign, where the other one's connected by an add. And again, the second parenthesis looks pretty much the same, except for those signs in front of the ABs. So the thing to remember here, so you have this thing, remember to use SOAP. And so SOAP stands for same, opposite, always positive. So what I mean by that is if this sign is a minus, then we're going to have the same sign there. The next sign is going to be opposite of what we have. So this one will be a plus. And then that last one is always going to be positive. All right, and so down here to kind of illustrate, right, we've got a plus sign is how they're connected. So our first sign in between there is going to be a plus sign also. Next one is opposite. And then the last one always positive. So that's just kind of a way to help you remember some of this, because really you have to have this memorized going into the exam. You can't really factor these any other way. So, and sometimes students look at this and go, how could that, really be this? So I'm just going to take this one up on the top and we're just going to verify it, meaning I'm going to distribute that through, use the distributive property, and then we're going to see what happens when I do that.
And can you share your screen?
Oh,
Are
I
you
thought I
like sharing
was.
it?
Oh my gosh. Okay. Just once. Okay. So here we have, like I was saying, the same, opposite, and always positive. So we've got whatever sign is in front here is the same as that one. This one's the opposite of what we started with, and then the last one's always positive. And then the same thing down here. If we start with a plus sign, we'll have the same sign in between here, the opposite sign between there, and then the last one's always positive. So, so really just being able to, just knowing these and just remembering this SOAP, the same, opposite, always positive, is going to be really helpful. Okay, so let's verify one of these. So that means I'm just going to multiply these out and show you what happens, because it kind of looks like, how in the world would this be the factored form and you would get to that, right? So let's do this. So if we take our A and we distribute through here, I'm going to put it over here, I'll have A cubed, and then here, right, I get A squared, whoops, I'm at plus, A squared times B. Take my A and multiply it by this one, All right, then I get a plus b squared. Oh my goodness, I forgot my plus sign again. So let's see, plus ab squared. And now I'm going to distribute my negative b through. And so when I do this one, right, I've got negative a squared b, and that's the same thing that I have right there. So I'm going to put it underneath here. So I've got minus a squared b. And then when I distribute here, I get a negative ab squared. So I'm going to put it under this one. And then negative b times b squared will be negative b to the third. All right, so we can see when we combine our like terms on this that these terms here in the middle just zero out. All right, and so that's why this happens, and then we're just left with that a cubed minus b cubed. All right, and so yeah, so we can go back and forth between those different forms. And remember, when we say something is in factored form, that means that it's connected by multiplication. All right, so we have this connected to this by multiplication. So that's in factored form, where this one is not factored because it's connected by a subtract sign. And same thing here. This is not factored because it's connected by an add. So just kind of keep that in mind on this. Okay, so let me show you how we're going to go about doing this, because these A's and B's are important to understand, and sometimes you can't just, like 27 and negative 64 on problem 1 are not my A and my B. So notice how I need to have it in the form as a cubed minus b cubed. So I need to rewrite this and figure out what my a is going to be, because I need to have something cubed minus something cubed. All right, and so when I'm thinking of, what number cubed gives me 27, well, that'll be 3. And what number cubed gives me m cubed? And that would be just m, right? If I take m and cube it, I get that. All right, and then 64, and it's good to make sure that you know some of your perfect square trinomials, or sorry, just your perfect cubes, I meant. So some of the perfect cubes would be 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. So knowing at least up to there would be really helpful, just to recognize 1, 8, 27, 64, and 125 are perfect cubes. Because then I can see on here that I have, what cubed gives me 64? Well, that's going to be 4. Right? So now I can see that I have my A is 3m and my B is 4. And so those are the numbers that I'm going to be using in this formula. All right, so now I'm going to look at this, and it's really kind of probably the easiest type of factoring as long as you have this memorized. So if I go and do my first parenthesis, A minus B, well, my A is 3m, and my B is 4, and it says minus it, so minus 4. All right, and then in my next parenthesis, I'm going to write this down kind of might look a little bit different, but I'm going to write it down as 3m all squared, because I need to take whatever that A is and square it. And remember, I'm not going to, having 3m squared like that is not the same thing as having 3m squared like this. And this is the one that we want. We have to take that whole thing and square it. All right, so I'm going to put it in parentheses here. 3m, we'll square that. And then we'll have plus a times b. So a times b. So I'll I'll just write it down this way, 3m times 4. And then the last term is going to be plus b squared, and so I'll write that down as 4 squared. All right, and now I just need to kind of simplify that last parenthesis, and I'll be done. So that 3m minus 4 stays. On this one, 3m times 3m is 9m squared. And then 3m times 4 is 12m, and 4 squared is 16. And so that is what you come up with for your answer there. Oops, let's see, yeah. All right, and then I always say at the end, you know, check to make sure you use SOAP because it's easy to get those signs mixed up. So I'm like, okay, I started off with a minus sign, so same, opposite of that, always positive. Yep, I did it. Okay. All right, let's look at a couple of them here. On this one right here, I want you to notice that there is a greatest common factor. And with any kind of factoring, we want to make sure we always take out that greatest common factor first. So let's go ahead and take that out. So if I do that, factor that out, I'm left with t cubed minus 1. And remember, 1 is a perfect square. That's probably the one people forget about, that it is a perfect square, because 1 times 1 times 1 is just 1. All right, so this time when I'm looking at this, I have this 8 in front, and it's going to be part of my answer, but it's not going to be part of the A's and B's that I'm dealing with. All right, so I'm going to keep it there as part of my answer, but then remember, I'm going to rewrite this, you know, so t cubed, t all cubed, minus 1 all cubed. So I just want to make sure it's really clear what my A and my B are, and that's why we're rewriting it that way so we can see it. So t is my A and 1 is my B. Okay, and then if I use this, so I'm using the same one up here, we'll do one with a plus sign here next, but we're using that same one, so make sure that you have the 8 out in front. Don't forget about it because sometimes that's easy to forget about. In the first parenthesis, we'll have a minus b, so that means it's going to be t minus 1. In the second parenthesis, we'll do a squared, so that's a t squared. And then a times b, and it's going to be minus a times b, so that's just going to be negative t when I multiply those together. And then the last one is b squared. Whoops, why did I put minus? I meant plus, right? And then the last one is going to be 1 squared, which is just 1. And then again, check to make sure you use SOAP, right? Same, opposite, always positive. And so that would be your answer. All right, any questions so far?
Not for now.
Okay. All right, well, let's go to problem 6 next. And so we can do one with a plus sign in between instead. But really, it's still the same kind of idea on this that we're doing. All right, so let's rewrite this as something cubed plus something cubed. Oops, that looks like a T. Well, that doesn't look much better. Sometimes this tablet is not easy to write with. Okay, so looking at this, all right, so I'm trying to think of what times what times what gives me 64. And again, if I have these memorized, it's easy to see that I have 4. But I don't just have a 4. What else do I have there in the parenthesis? 10? Yeah, we got an M, right? Because I need to take that M and figure out, you know, M times M times M gives me M cubed. All right, what are we going to have over here in the second one? What do you think we'll have there?
An N?
We're going to have an N. And what about the 125?
5n.
Yeah, so 5n. All right, and so now we have our a and our b, right? So we can write this out. All right, so let's see here. So what's going to go in my first parenthesis?
That would be 4m plus 5n.
Yes, exactly, right? Because we're just doing our a plus b. Awesome. Okay, and then our second one, we need to take our a term and square it. So again, the whole thing needs to be squared. So let's do 4m all squared. All right, then my second term, now notice here, all right, I'm using SOAP, right? So this is the same. So this next one needs to be opposite. So I'll put in minus there. But then I'm doing 4m times 5n. And then my last one will be plus, and now I'm going to take that 5n and square that whole thing. All right. And you don't have to write this step down if you can do that part in your head, but be really careful because, like I said, the most common mistake I see here is that people will write that, like that 4m all squared, they'll just write it as 4m squared. And there, only the m is being squared, but we need to make sure that we're squaring both of those things inside. Okay, so the first one's going to stay the same though, that first parenthesis, 4m plus 5n. Here, 4m times 4m is 16m squared. Multiply those together, we get negative 20mn. And then the last one will be plus 5 squared is 25, and then n squared. And so that is your answer, and you're done. And then I just say, just check to make sure you have your signs right, same, opposite, always positive. So it looks good there. Okay. And sometimes the students wonder about like this middle term right here. Like, do I have to write it as mn? You could write it as negative 20nm, the other way around, but usually in math we try and put things in alphabetical order just to keep things organized, but the homework will accept it either way. So just it's just a way we do things. Okay. All right, I'm going to skip over that first challenge problem because you're not going to have anything like that. You might see them in 1050, but if you want to try it later, you can. But let's look at this one because this does tend to kind of show up here. And it's a little bit tricky because we have, this to the 6th power. So we don't have something squared and we don't have something cubed. And so we're thinking, okay, am I using is it a perfect square or a perfect cube? All right. And so when I'm thinking about this, well, 9, is it a perfect square or a perfect cube?
A perfect square?
Yeah, it's a perfect square, right? We have 8 as a perfect cube, but 9 is not, right? 9, we have 3 times 3 gives us that. So when we're looking to try and do this, right, we're going to, think about, okay, if I write this, let's see, let me actually give myself a little bit more room here, just because this pen kind of is big. So I'm going to just put this 3 because I want to have it as something cubed minus something cubed again. All right, but now let's see, this first one, if I took just x squared and I raised it to the 3rd power, that does give me x to the 6th, right? But also the other way, if I had x cubed raised to the 2nd power, that also gives me x to the 6th. So we have to kind of figure out which way we want to do this, right? And so inside here, if I'm, thinking of this, I'm going, well, wait a minute, can I rewrite this as something all cubed? And I can't, right? Because I just said 9 has to be something squared. So even though like this is kind of in the section where we're doing the perfect cubes, you're going to see that that difference of cubes is also going to come in here. So let's try it the other way around, kind of like I wrote here, and see what we can do, right? So if we have it something squared minus something squared, well, then we'd have x to the third squared, and here, right, if I take 3 and square it, I get 9. And if I take y to the third and square it, I get y to the 6th. Okay. Is that making sense? I know it's a little bit weird because it could be written, well, it looks like it could be written either way, but on this problem, it can't. You have to do something squared minus something squared, and that's because this is a perfect square, not a perfect cube. So it's kind of like we have two problems in one almost. So, okay, so let's finish this up. So remember our difference of squares, we said a squared minus b squared equals a plus b times a minus b. All right, so we did that back in the factoring, or like 3.5. We talked about this. And so, again, if this is my A and this is my B, then I can just kind of follow this to figure out what my answer is here. So I've got, let's see, my first parenthesis, A minus B is going to be x cubed minus 3y cubed. And then my second parenthesis is going to look just the same, except now it's going to be connected by an add sign. I did the minus one first, but again, it doesn't matter which one of those factors I write first, right? These are connected by multiplication, and with multiplication, that order doesn't matter. 2 times 3 is the same thing as 3 times 2, right? Order doesn't matter. Where with like subtraction, it does matter which order you put things in. Okay, so then in our other one, we'll have x to the third plus 3y to the third, and then that will be done. Okay, so I think on the homework there might just be one question where it's raised to the 6th power. So that's what I remember, at least. Maybe there's 2, but I know there's at least 1 on there. Okay. All right, so the other thing that I want to look at with you, and let me pull this up. All right, so this is a factor flow chart, and I'll send you a copy of this so that you can have it to use. You won't be able to use it on the exam, but it's nice to have when you're working through things if you get stuck. Okay, so if we, go through this, we're saying, okay, we first got to factor out the GCF. That's always, always, always going to be the first thing that we want to do there. Oops, let's see here. I just moved that the wrong way. So we're going to start with looking at factoring out the GCF. Right? Sometimes there's not a GCF, so you wouldn't have to worry about it. But if there is, make sure you always factor that out first. Then you're going to ask yourself, what kind of polynomial do you have? Do you have a binomial? And remember, that means, does it have 2 terms? Do you have a trinomial? That means, does it have 3 terms? Or is it a 4-term polynomial? All right, so you got to identify what kind you have there. And so the ones that we were doing today, right, were these perfect cubes. But notice these binomials, and this isn't all the time. Sometimes we could have something like 2x squared minus 4 or something. right? And that's not necessarily a difference of squares because we can factor out that 2 with it, or even if I put like an x there, factor out a 2x, and then I'm left with x minus 4. So just because it's a binomial doesn't necessarily mean that it is. So what you're looking for is, do you have something squared plus something squared, or something squared minus something squared? Now, a sum of squares can never, ever, ever be factored. And so that we call prime if it's not factorable. All right, so if you have something squared plus something squared, it can never be factored. But like we did on that last problem, if we have a squared minus b squared, that's a plus b times a minus b. Right? And so you're looking for perfect squares. So look for the numbers, like 1, 4, 9, 16, 25, and so on, right? As the coefficients. But also look for the squareds in there, okay? And then the perfect cubes, and you're looking for, is it something cubed plus something cubed, or something cubed minus something cubed, and look for those perfect cubes. That's what's going to clue you in on, which one you're going to be using. Now we did stuff before on 3.5 where we talked about this factor by grouping. So notice if I start off with a 4-term polynomial, you're going to usually want to do this factor by grouping. Okay, again, this isn't like all the time, but most of the time when you have 4 terms, that's going to be the way you're going to want to do that. And then when you have a trinomial, you want to kind of think about, if A and C are a perfect square. If they are, then you can use this perfect square trinomial formula. Or if they're not, then you're going to turn it into a 4-term polynomial. And you could do the factor by grouping. You can do the box method. I didn't teach you guys the synthetic method, but it's a really cool way to do something. Maybe I'll show you on one of these next ones that we're going to be doing. So it just kind of helps you to know what kind of factoring you need to do for the different types in case you get stuck. Okay, because on 3.7, after you do this sum and differences of cubes, there's going to be some where it just takes you back and you're just trying to figure out just factoring that we've done before. Okay? All right, so looking at this one, we can see, all right, this is a trinomial. And so first thing I want to do is look to see if there is a greatest common factor. Can you see a greatest common factor there?
2x?
Yeah. So let's factor the 2x out. So that means we're dividing each of these by 2x. So that's just going to leave me x squared plus 5x and then minus 4. And sometimes that might be all we're able to do, but you want to look to see if that trinomial can factor further. So you're thinking, what multiplies to be negative 4 that adds to be 5? So the only thing that I have, I can do 1 times 4 or 2 times 2, right? And so on this one, if I'm trying to factor this, is there any way that I can get a positive 5 there in the middle?
Why is it negative 4 if we're multiplying 2x?
Oh, it should be, I'm sorry.
Yeah.
You're
Yeah.
right. It should be what?
Negative 2.
Yeah, it should be a negative 2 there. All right, negative 4x divided by 2x. It's just going to leave me a negative 2. All right, so let's look at that now. So will that factor? Well, the only thing that we have on 2 is, 1 times 2 is the only thing that gives us 2. And there's no way that we can get that to add to be 5. And so this means that we'd be done here. We can't factor this any further. So, but you want to look to see if it can factor further. All right, but that's all we can do on this one. Okay, how about this one? Again, when we're looking at it, we're thinking, okay, I've got to start off with a greatest common factor. And I can see that 3x is my greatest common factor. And if you're not sure if 3 divides into 48, just do it on your calculator and you'll see it does. All right, so when I factor out that 3x, now I'm left with x squared minus 16. Okay, so this x squared minus 16, can that factor any further?
Yeah, isn't it a difference of squares?
It is, right? So it's just like this one right here, this difference of squares. So let's go ahead and factor it that way. So 3x stays out in front. And what are we going to have inside here?
X and 4?
Yep, so x plus 4 and x minus 4. Right? And then that is done. That is all you can do on that factoring. Okay, but notice how, like, looking at it, you're going, okay, there's two terms, you know, are these perfect squares or perfect cubes? That's going to help you kind of figure things out a little bit more on this. All right, let's see here. Yeah, let's do problem 11 also. So can you see a greatest common factor there?
3?
Yeah, so let's factor 3 out. So that's going to leave me with 2x squared minus x minus, and when I divide that by 3, I get 21. All right. And then now I have to look and see, like, this is a trinomial. I need to see if it can factor further. But my leading coefficient here is not a 1. So remember, I can't just say what multiplies to be negative 21 that adds to be negative 1. I've got to multiply those things together, right? So 2 times negative 21 is going to give me negative 42. And so I'm trying to think of all the things that would multiply to be negative 42. So, and you can just like work organized through it, right? 1 times 42, 2 times 21. Let's see, does 3 divide into it? It should. 3 times what?
Sorry, are you asking me?
Oh, yeah. Yeah, so
Oh,
yeah, 3 times what gives you 42. So we'll just divide it out, right? 42 divided by
14?
3, yeah, is 14. Okay, and 4, it won't divide into it. 5 won't divide into it. 6 will. 6 times 7 is 42. And then there's no numbers left in between 6 and 7, so we know we found all of our possibilities. So which one of these possibilities could add or subtract to give us a negative 1?
Negative 7 and 6.
Yeah, we want to make sure that negative is on the 7 and a positive 6. All right, and then we can turn this now into a 4-term polynomial and do factor by grouping or do the box method if you like that way. But make sure you keep that 3 out in front. It's still part of our answer. Okay, and so this first term of that trinomial stays. But the middle term, that negative x, is going to change to plus 6x, because of what we found down here, minus 7x, and then minus 21. Leave that last one the same. Okay. All right, now let's go ahead and split that down the middle and do this. So I've got 2x is my greatest common factor of those first two terms, and that's going to leave me with x plus 3. Right? 6x divided by 2x is 3. And then here, since this is negative, we want to make sure that we factor that negative out. So if I factor a -7 out, I'm left with, again, x plus 3, which is what I needed, right? I need these two things to be the same. If you don't get the same thing there, then you probably did something wrong. So, because they're all going to work out nice for you to do that. All right, so we've got the 3 out in front. X plus 3, all right, is the common factor with these two terms, so it goes in one parenthesis. And then our leftovers, stuff that's out in front there, goes in the other parentheses, so 2x minus 7. And now that's all factored. We can tell it's factored because all of these are connected by multiplication, right? Multiplication, multiplication. All right, any questions there?
Nope.
All right, well, I think we're just going to stop there. Make sure you remember to get your written quiz for Module 3 done and your online quiz. And let's see, the due dates for those, I think they're due tomorrow night by midnight. So,
Yeah, February 14th.
okay, yep. So that's what we'll kind of do there. All right.